Great. Hello, everyone. My name is Mark Cavens. I am the product manager here for, one of the product managers here for Chef. And today we're going to have a conversation about Chef 360 versus some of our competition. And hopefully, as we look through this conversation, we'll be talking about how do we deliver ROI value with Chef 360 against some of the things that our competitors do today. As we forward into what the agenda will look like.
Sorry.
Yeah, we're going to have a little bit of a focus here to talk about what the agenda of everything that we're going to be talking about. We're going to be talking about some of the value that we're going to be showing and delivering as a part of Chef 360. We're going to be talking a little bit about how we compare with Ansible and Puppet and some of our other competitors. We'll do a little bit of a deeper dive into the Chef 360, and then we're going to have a conversation with myself and one of our guests here, Mike Butler, and talk a little bit around what does success look like and what have we seen with customers both now and in the past. And then we'll end up things with a little bit of Q&A as, and again, give people time to answer questions and think about if there's anything that you think that we might have missed as we're giving our presentation today, and allow you to ask those questions to where we can fill in any of the gaps that you might have. Before I hand it over to one of our first speaker, Kimball Johnson, what I'm going to do is just kind of give an overview around the DevOps and the way of life that really our customers and throughout the different organizations have really started to adopt. We see almost 100% adoption of the DevOps mentality and see impact based upon that mentality of having gateways, pressures, and levers all put through within the organizations themselves. Everyone has a tool, and unfortunately, in a lot of cases, people are using multiple tools to accomplish the same objectives that they're looking for. One of the things that we'd like to talk about today is being able to either augment those tools or see a reduction so that you can start to see a return on investment as things start to progress in your DevOps journey. One of the things that I want to take a look at is while we do see almost everyone looking at a DevOps way of life, one of the things that we do want to get before we start talking through things is the ability to gain a little bit of insight to those people that have joined our webinar today around where you're at with your DevOps journey, as well as the tools that you're looking to today. So I'm going to start a poll. We'll give it about 2 or 3 minutes. And then after that, Kimball Johnson's going to take over and talk for a little bit before I come back online a little bit later on in the presentation. We'll give just a few more seconds here and then we'll take over. All right, I'm going to end that poll, and Kimball, go ahead and take away with the next part of our presentation. Thank you all.
Thank you, Mark. You can leave the poll running. Actually, it will just let people give a bit more time. I can carry on while it's running. That's not a problem. Yeah. Okay. Well, thanks, Mark. So what I'm going to be talking about is like some of the infrastructure automation challenges people are facing. This is sort of executives, but it's also practitioners as well, and some of that how kind of the two are related, like what the challenges that practitioners have, and how those map into the challenges that executives have. And I'll cover a little bit of that as well as I'm going through. So this is a big thing, is that like concerns that we've seen from customers, and this is not just from customers. This is also backed up by Forrester and Gartner. They have research that backs up these same things as well. And it comes down to people have, and even if they're using DevOps, they have these like slow and risky infrastructure changes, especially if you've got more complex environments spread across multi-region, for example. There's like this ongoing operational risk that people have in terms of like any kind of downtime can be much more of an issue. There's constantly, we're seeing more and more problems with vulnerabilities, both at the software and at the network level. And as a result, you get people with like a lot of manual effort ends up happening. And what tends to happen is that we get into this kind of disaster loop where you have a problem with scale, and there's risk and toil, and so you'll get more tools, and that can be a little fragmentation of tools between teams, because different teams are finding they have different challenges, and so that blocks like kind of the standardization and the changes, which then means you have more manual processes which slow things down again, and then you get more drift and more outages, and you don't have, and as a result of that, like this manual process, you've lost all your auditability, and so if the scale is amplifying this again, and so you add more tools, and it just goes around and around in a loop, and this is a really bad situation to be in, and these challenges all like reinforce each other, and it's not a problem with the tools as such. It's a problem with the system. And this pain compounds unless you can change your system. And I just want to sort of talk a little bit about the different products that exist out there, and like why some of these things happen. And obviously, I see that people have been using Chef, people have been using Ansible and Puppet, and different tools have their different benefits. Like Ansible is really, really quick to use for a simple use case, get starting up. The YAML based configuration is often seen as easier to deal with, but you do kind of start to get into complexities as you're trying to do more complex tasks. The same thing happens with the other tools as well, Puppet and SaltStack, and even to an extent, Chef will have complexities as you're getting to more complex problems. But what we've done with 360 is we're trying to make it, trying to kind of manage that complexity by designing for complexity from the ground up. So whilst the individual tools may have their complexity, the Chef 360 platform is designed to handle that complexity. It's designed to give you this multi-step automation that's right away. It's designed to have all your scheduling is enterprise grade in there, and your visibility. And we can see that, like organizations that want their return on investment high have seen benefit from it. And a bold claim, I understand. So let's back that up a little bit. It's very easy with Chef 360 to get your first automation live in days, not months, not anything like that. It's a nice, quick thing to get going. Out of the box, it is very, very simple. But speed alone isn't everything. We need to control. So we have the native scheduling. We have the ability to have the visibility across 1,000 nodes in a single dashboard. This produces productivity very quickly. You don't need the specialist tools, any special roles. It's very easy to use the platform, just sort of as any kind of member of the team. Especially in terms of like gaining insight into what's going on, and this is really helpful for us. This will allow you to break that loop, because you've got a single automation control plane that can manage multiple other tools. And as we've talked about in previous webinars and stuff, you're not limited to just managing Chef with it. You can manage Bash scripts, you can manage Puppet manifests, you can manage Ansible playbooks, you could manage Kubernetes and all sorts with 360. So it gives you that kind of that single control plane, I don't want to use the term single pane of glass, because this is more than just that. It gives you the visibility, but it also gives you that operational stability. So some of the benefits that we get, and this is not the benefits from 360. This is the benefits you get from having this controlled platform, this system whereby everything is in the one place. You're understanding orchestration rather than individual scheduling and individual controls. We're able to get fewer incidents. We're able to get faster deployments because the testing is built into it. Your downtime recovery is much quicker. And you'll have a much faster onboarding for individual users, but also for new projects and platforms, because of the way that the system is designed to be so simple and easy to use. But as I said, it's not just about the system; it's about the idea of the system. So it's not a 360 specific thing, but by having our platform, we make sure you get all these benefits. So specific problems that have been solved by Chef 360, and these are things that we have seen in our customers. These are things that that we have experienced ourselves in terms of setting up with trials and demos and stuff with people, and the feedback we've been given from our customers and others. Slow, risky infrastructure changes are changed, because instead of having able to deploy, a complex multi-platform system with managing the interdependencies manually, we're able to do this with predictable, repeatable automation and scheduling. Emergency incidents that are driven by inconsistency, these were reduced by having a much more consistent system state, by managing all of your automation tools from one place. This is a really big one. A lot of systems, they break because somebody's off, and that particular bit of knowledge is only in one person's head, or it's been documented, but it doesn't really make any sense because it's just like a brain dump from someone. By having proper standardized workflows that anybody can execute, and clear runbooks that refer to those workflows, you don't have this kind of operational knowledge trapped with a single person. It's built into the system. We don't have any compliance uncertainty and manual audits. Everything and this is something we've been doing for years. You have continuous compliance. The compliance can run daily, twice a day, maybe even more frequently, depending on the level of checks you're doing. And that gives you these audit trails that are all automated, and the compliance using the Chef inspect language allows you to have a human readable description of what's going on. And then the code is designed to be very simple to understand, to verify that human readable system, producing an audit report that you can present to an external auditor and go, yes, here is the proof. This is where we are. And we don't need any manual toil. Everything's being automated, and adding new things, one-off tasks can run through the same scheduler. And so we reduce that manual toil, and that means that the engineers can get on and work on the things that the engineers want to work on, which is developing new features and improving the return for the company. And this is where this is something that helps the engineers, and it helps the management, because when your engineers are happier and they're able to get on and do more interesting work, that more interesting work is delivering business and features, rather than delivering maintenance and break fix. This makes your engineers happier because they get to do more interesting work, and it makes your management and your executive happier because they're getting to actually produce, see their engineers are providing value to the business. So some typical return on investment. This is things that we've seen from many customers throughout all of the Chef automation era, and particularly within the 360 and the tooling that 360 platform gives you. Much faster time to compliance. You're able to roll out a policy update across thousands of nodes in, well, you can run the scanning can happen in hours, and then the remediation can happen in days. You don't need, your operations team is productive. They're not having to spend time on break fix or manual toil. They're able to actually build more interesting things and deliver more value to the business. Deployment time is reduced. This is a big, huge thing. 50 to 70% reduction in deployment time because everything is streamlined and automated and the tests are built in. I mean, this shouldn't be new for anybody. This is standard kind of impact you'd expect when you've got a smooth automation system on your platform. The big thing here is the kind of savings that you can make by consolidating tools, by reducing your out of hours response and the payments that would be required for overtime and out of hours, removing the number of licenses you have for tool sprawl. You can see up to $2 million of annual savings. This is not an insignificant amount of money for any business. And then, of course, the lower risk and audit costs. And the big thing here is risk for problems. Like, there's the monetary risk, there's the time it takes for an outage, but the reputational risk, if you get some kind of like major security breach, the reputational risk can be irreparable. If using tooling like this, the constant auditing, the constant compliance, then the assurity that your deployments are consistent and well understood by everybody that's involved with them, that will massively mitigate your chances of that huge reputational risk from a severe breach. So how do we do this? I've talked in a high scale about the sort of benefits that we want to do. Well, how do we actually do this? What can I put behind the words I've given you so far? So, the operating model of Chef. We've got. I'm not going to talk specifically about the individual capabilities right now. I'm going to talk about the things that it is trying to achieve. So we're talking about the development and test process, how we can create and test our policy before enforcement, the ability to ensure that the changes we make are safe, the ability to ensure that the system is in the state we want it to be, both for the standardized things, but also for being able to do emergency changes. And these are the things that we want to allow. Compliance and security. We want to make sure that we're constantly secure and in compliance, and we want to ensure that that's quick. And the velocity of security is really important. Things like shifting left so that you're able to not find that security is a blocker in your deployment. And then the other thing that's really important, and what we have right, is the data aggregation and validation. Having the ability to see what's going on. This is a huge important part of what Chef can do. But the thing that's really important from this is that 360, it's not, well, it is a collection of tools, but it's not. We're not presenting it as a collection of tools. Chef 360 is a control system. It allows you to have that understanding control over all of these tools that we use, both the tools we produce and other tools that you may want to integrate. So what have we got that does this? Well, the control and execution, that's, the Chef Courier, the Chef Infra and the desired state model, the awareness, the visibility, understanding the nodes that are on the system, the reporting that is produced, the policy assurance with InSpec. And then, of course, there's authorization and role-based access control and APIs, so that this platform is an enterprise level system. that you can control both through the UI that we provide or through your external tooling that you need through the APIs. So what have we got to do that? Well, the job orchestration. This is a hugely important part of Chef 360. This is what allows you to allow any action on wherever you want, any set or subset of nodes at any time. The whatever, wherever, whenever. So we can set up schedules that are instant or at some point in the future. We can set up things to run on a repeated schedule. We can make them run in such a way that if you're doing a big change, it will start to run it on a set of nodes. And it will do it in a kind of controlled manner, so a few at a time. But if it starts to fail, then it will stop running the job. Or if you want it differently, you could have it so it rolls back the ones that fails but continues on the others, depending on how you want to set it up. And that's all stuff that is part of the orchestration, the Courier platform. But as I say, the important thing here is the whatever, any action. So you can have it run a chef inspect test. You can have it do a chef client run. But you can have it deploy a Puppet manifest or run an Ansible playbook. And these are things that we can do as well. You can have it run bash scripts if that's what's needed. You can have it make a change to the Kubernetes infrastructure. Any action. And on any system that you have built onto the Courier system, be that a system that you can run directly onto, so it's a natively running on it, or something that you're accessing through the Chef target mode with Chef 19. All of these things can be handled, and you, as we said, at any time, immediately, right now, or at some time, defined time in the future, and on an interval repeatedly. We manage the infrastructure. So our code. This is the Chef infra system policy as code, so that you are able to test it, and you're able to version control it. You're able to deliver it at scale. We can manage hybrid systems that are on-prem, cloud, everything. It doesn't matter what operating system is running or where it is. It can be handled through Chef, or if not through Chef, through a different system by being able to run using Courier to deploy to it. This allows us to eliminate the drift and the misconfiguration and minimize the vulnerabilities and the variability of your system. Because especially as everyone should know, if they've been using Chef or any kind of desired state management infrastructure system, the changes only get made if they need to be made. The idempotentness of all of these infrastructure systems, right back to CF Engine in the early days, and the flexibility. So this is one of the ways where Chef shines. You've got the Chef resources, the huge number of resources that are built in that you can just use declarative, simple definition. But if there's something that's not there, you can add to it with custom resources, which is not complex. And it doesn't require any additional tooling to be able to create them like you might in some other systems. And so it's very easy to just define and control whatever you need. And then compliance. Compliance, again, is taking the infrastructure as code that we've talked about in the past and adding testing as code and auditing as code, compliance as code, allowing us to build it as part of your standardized testing suite. Simple, understandable code that is easy to understand, is easy to assign a priority to it, an impact level to it, and allows it to make compliance just a behavior of the platform, not something that is a slog to do, but it's just always there, always available. Evidence is always there. It's always happening. and the compliance is you know, it's as to say we provide the tooling for the controls from standardized things like CIS, and they're there as this excuse me, it's there as policies that you can apply to your system very easily, and remediate very easily with code, and then get the reporting through the 360 platform, the automate, and then also into external systems, into your ServiceNow when there's a problem, to raise a ticket, or your continuous monitoring. And to top it all off, we talk about Chef SaaS, software as a service. So not only do we have the wonderful platform that makes life easier for you, we'll manage it for you as well. We've been managing various types of Chef SaaS services for many, many years, 10 years at least. This reduces your operational costs. Maintaining a platform is, you know, there's a cost. It's not the core to your business. Your business is not maintaining infrastructure as code or automation platforms. That's our business. So let us take care of that. And you can look after your business, whether it be, you know, whether it be creating, manufacturing or engineering parts, creating your own software, you know, selling sandwiches, whatever your business is. Let you take care of your business, and we'll take care of our business and the SaaS system for you. Automatic upgrades, much faster time to value, and the same intuitive UI that you would have if you installed it yourself locally. So what does this give us? We're going to move on to discussing a long-time chef practitioner. And I want you to think about that as we're doing that, is that what DevOps looks like in practice. We've got safe changes and consistency. We've got the ability to scale easily, and we can have secure and compliant infrastructure. So just whilst we're having the next discussion, think about these things. Think about what is the successful DevOps, and think about how the tooling we have and the systems that we have spent so many years working on, and the understanding we have, how that will provide that DevOps success in practice. And with that, I'll pass back to Mark, and we'll have a discussion of what success looks like.
Awesome. Thank you, Kimball, for that time, and also for the discussion points. During your conversation, there were a couple of questions that will come through. Some of the information I think we gave a little bit to, but after our fireside discussion, we'll also directly answer those questions and delve into them a little bit more, because the questions that I've seen have been quite interesting, and I think that they deserve a little bit more time than just typing out what we think those answers might be, and we actually have a discussion around them. So hold tight on those questions, but keep them coming, and we will answer them at the very end of this session with as much information as we can get. With that in mind, I do want to talk about our fireside discussion, and I want to introduce to you a very special guest that I've had here. You know, I'd like to introduce Mike Butler. Mike is a longtime chef advocate, and for the last 4 years is actually a solution architect with our team here at Chef, spreading that chef and DevOps love. Mike, if you want to do a quick introduction and talk a little bit about yourself.
Absolutely. Thanks, Mark. So as Mark said, my name's Mike Butler. Geographically, I'm located in Orlando, Florida, and if you're ever down this way and want some park recommendations, feel free to reach out. So as Mark said, I started working with Chef as a customer in 2016. I was lucky to go to ChefConf that year, and a few other DevOps days. Really had an aha moment of how awesome DevOps is, and Chef specifically, and how well it fit into it. So I was the product owner of Chef at a large healthcare services organization. We managed and supported Chef across more than 70,000 nodes. My responsibility there was running the team that supported the platform. I assisted a lot of the internal customers with enablement, along with my team and drove adoption and provided guidance around all things Chef and really DevOps. Love the product so much that when the opportunity arose to come to Progress and be a solution architect for Chef, I jumped at it. A lot of what I do today isn't that much different than what I was doing before. It's just a little bit larger scale, handful more customers, get to play with all the cool stuff early on, and have labs that I'm not afraid to break stuff in, and lastly, just having amazing conversation with all of our awesome practitioners.
Awesome. Thank you for that introduction to yourself, Mike,
Yeah.
there. I want to get into the actual conversation and get to the meat and potatoes. So the first thing I want to talk about is the core functionality of Chef, particularly the as-code approach to configuration management. Our goal, of course, is always to keep systems persistent across environments and prevent drift. Our customers do Chef infra client runs on a schedule, so it can gather local system data, sync cookbooks, converge state, then run the compliance phase and the compliance as code. We also have that added benefit of adding both the agent and the agentless SSH runs where needed. My first question to you, Mike, is how often do you see node coverage with other solutions, and how often do they need to do that run?
Yeah, I think it really depends on product and industry as well. So with Chef, we generally recommend converging every 30 minutes or checking in and updating every 30 minutes. And managing that check-in time is very simple to use with Chef. We have resources that make it very easy to manage and configure that. But a lot of folks that are using Ansible are a lot what I hear around, they're really concerned about build time. Like we just want to, we have our playbook, we're provisioning a machine, or if they could be using a provisioning tool, the same thing, running scripts, get that build out and go. A lot of folks that are using it in that space don't really go back and redo or replay those playbooks. You can, but generally it's like, hey, I just need to get this thing delivered. So, always with Chef, we're looking at that bigger picture of like not just at build time. Like we definitely can help with build, but it's the continuation and keeping that drift from occurring. So like someone logs into it and changes the machine, now you have your non-prod and your prod environments different. That's always been the purpose of Chef and tools like it. So really the goal is around item potency, meaning it only changes it when it needs to change. When you're using shell scripts, it's really complex to build in item potency. And this is one of the powerful things that you can do with Chef. The Chef DSL is honestly pretty simple and just takes care of it. So like if you configure the setting, it will validate whether it needs to be applied or not, and then gives you the output of, hey, this was already in the state it should be in, so I didn't need to do anything. Trying to do that with playbooks and other tools, or just scripts in general is very complicated to write that validation piece.
Sure, thank you. So what other benefits do you get from the full client run?
Yeah, you kind of ran through them at the top of this part of the conversation. So first thing that happens during a client run is we gather thousands of points of data, or attributes as we call them, at the beginning of the run. This is used by our tool called OHI. It just grabs the information, and then all of those attributes that it grabs, you can use them within your code, your configuration code, to either build templates. You can use it to validate, say, hey, am I in US East 1 or US East 2, and then take different like DNS settings. So all of that data at the beginning that it grabs is really, really important to be able to extend the use of Chef across many platforms and a lot of variants. Again, this is something that, if you can't gather the data about the system from the system, then it makes it a lot harder to do that logic inside of the code. So the other good thing about all of this data is that it's all collected and you can use it's collected in our reporting tool. You can use it and find out what applications or packages or whatever is installed on certain systems. And then you can also move this all to the CMDB as well. So the other thing I want to point out is at the end of a client run, ever since client 17, we run what's called compliance phase. This is a test that you wrote, that inspect test that you're doing your auditing with. You can actually take your test that you wrote for your development and expand that and then run that and make sure that all those systems are compliant. Another really nice feature about this is that you can first go and update your inspect test and check to see if there is a change or that a certain setting is a certain way, and then go back and apply the configuration to enforce that setting. And then that just goes even more and more and more extensible as you go. So yeah, it was implemented, I think, right when I came in here at Progress. This is one of the features that I would have loved to have had when I was a customer, because we constantly had app teams saying, hey, I need to know how my particular application's configured because I've got to do reporting, right? So in heavily regulated areas, like that is very important that the application teams also provide the reports.
Awesome. So you mentioned as a part of this, creating the compliance profiles as a part of the development and testing process. A common chef workflow is the use of workstation to scaffold, lint with cook style, running test kitchen, and inspect locally before publishing cookbooks to either your server or your repository. In your experience, are developers running only acceptance tests before merges today with other tools?
Yeah, again, I think this really depends on what your config management tool is. Regards to Ansible, at least when I have worked with Ansible, I generally just provision a server in a sandbox environment, and then I work on my playbook, and then I apply it, and then I work on my playbook, and then I apply it, and I work on my playbook, and I apply it. But every time that I go and make a change again, I have to either rebuild or re-provision my server and start all over again manually, or like go in and undo the things that it did with my best ability. On the Puppet side, yeah, there is a lot of testing. Testing on Puppet is generally more unit testing using RSpec, which is Ruby's spec language. Writing tests in RSpec, I have found is very, very time consuming. It's more than a matter of, hey, did this thing, did it compile? Did it execute, right? Like that's relatively easy. But when you say, what are the outcomes? When you start trying to use that unit testing to validate your outcomes, that's where it becomes much, much more difficult. And you can actually spend more time writing good RSpec tests than you do writing the code itself. With Chef, you can have the best of both worlds. So we really like our customers to focus on the integration testing. So what did what I do actually work? And folks are still able to use that RSpec or what we call Chef spec in the unit testing for that. Did it compile? So the integration testing, that's all based on inspec, right? So you're writing an inspec test, and then you're saying, hey, did this pass? With that process of writing the integration testing and then provisioning, much like that provisioning Ansible. With Test Kitchen, that happens all automatically. You can create the test with inspec. It automatically provisions a test server on the platform of your choice. You can use your image. You converge and apply the configuration code, and then you can validate that that outcome with inspec. And then you destroy the sandbox image. If you need to go back and make some changes, you can just destroy the image, recreate it all through that automation process. It will go and re-provision. It'll test everything. So what's even better is that this the same process that a developer goes through can also be utilized within pipelines to ensure that the good code is being released. So that inspect test and that outcome, you use that same test in your pipelines to validate it, right? So that's really to protect those developers who are like, oh yeah, I tested it, sure, and then try to push something. So that'll catch those sort of things.
Yeah, we've all been there before, right? So you did mention inspect, but without taking too much time, can you go into that a little bit further? How does it help in production?
Yeah. So if you're familiar with inspect, it's Chef's compliance as a code tool. I like to think it more as a test anything tool. Inspec allows you to take an as-code approach to writing tests in human readable format and use that test to validate something is either true or false or otherwise like compliant or non-compliant. So you can take these tests and add them together and you get a compliance profile. You can test everything. So anything from is my server or cloud resource or container, are those compliant with the CIS benchmarks? Or you can actually just write a test that basically goes and pulls all of the information from your GitHub orgs and do something like, do all my GitHub orgs have copyright 2026 in the README file? Like it's crazy extensible, containers, anything, right? So for an integration testing, for instance, what we'd want to check is Nginx installed? Is it not listening on port 80? Do the results of the page say Chef is awesome? That's the outcome that we're talking about when we talk about those tests. So we can take that same integration test and then we can build and expand upon it in a compliance profile. So we can add additional tests to that really where our server should be. We're talking more than just the outcomes, but actually the compliance of the system. So one of those items might be related to like security needs. So like TLS should be 1.2 or higher. The service account cannot be used for login. So when you have this as a part of your compliance profile, now you can generate reports and satisfy those audit requirements that your systems are compliant to your compute policies.
Awesome. So one question that I continue to hear about, and I think you've heard it as well, and really what I think about it more is as a myth at this point in time. And I hear this all the time, is that there's an advantage of Ansible that it's easy and all you need is YAML. And for Chef and other softwares, engineers need to know Ruby or Python or other complex languages. How true do you think that is?
Yeah, I hear it all the time too on our calls too. So George Westwater, who's our director of engineering, wrote an amazing blog post on this back a couple months ago. I think we put the link in the attachments called Debunking the Ansible Myth. A couple things I want to point out around this. So if YAML or JSON is your thing, you can write cookbooks in YAML or JSON now. So you can actually call the resources and pass the things. There are some caveats. So a lot like Ansible, like item potency takes a little bit more work. But if you just want to make simple recipes and just go and execute something, yep, YAML JSON works fine. So next thing is, like, I would argue that writing in Chef is as easy. I would argue that writing in Chef DSL is easier than YAML to me. It's a lot less reliant on proper spacing and like JSON with all of the commas in the right place and the formatting. I find our DSL much easier to read. So inside of that blog post too, there's a couple of code examples that George shared that said, hey, this is what Nginx install looks like here and there. Folks think that Chef is Ruby. Like, yes, you can go in, you can do deep things, you can write custom resources and get more Ruby. But if you just need to execute and you want to be idempotent, it is super easy. You call the resource, you pass the parameters, you move on to the next thing. And then it has all the extensibility of being able to add all of the attributes in that as well. So you can do your not ifs, or if I'm in this zone or that zone, or if it's in this IP range. Next thing on my myth list is you can run Chef in an agentless model. So much like we talked about earlier today, that Kimball was discussing. So you can run Chef in an agentless model. Actually, our latest Chef client, the majority, if not all of our Linux resources can now be run in an agentless mode. You can also write your own custom resources and execute them. So this means you can configure systems that can't run a client, like network devices, white box server appliances, legacy platforms and OSs. So I'd love to dive more into that, but like we are kind of limited on time, so we should definitely have another conversation. And the other thing that I really like about this is that agent versus agentless, like I have a whole talk on zero trust given, and really like having an agent is definitely your best choice. Like you don't want systems reaching, you don't want anything calling into your systems. You want your systems initiating the conversations. And lastly, with the other thing with Ansible and debunking that myth is the ad hoc jobs. Always been a problem with Chef. Now that we have Chef 360 and Courier orchestration, you can run whatever, whenever, and wherever you want, and it's not just Chef functionality, but you can run anything, and you can do this all without SSH or WinRM.
Awesome. This actually goes into one of the first customer questions that came about, which is, what is Chef 360? Is it different than other parts of Chef? So can we deep dive into what Chef 360 is a bit more?
Yeah, absolutely. So I've been running Chef 360 in my lab for about 18 months now. So pretty much right after the 1.0 release, or right around the 1.0 release, built it in my lab. Have done a lot of things there. So what can be done? First, we have Chef Infra backend moving into Chef 360. It's now called Declarative State Management. It's the Chef Infra you know and you love. Has functions and features that of Chef Manage that have had gone away. Now they're back. It's really cool. Lots of good ACLs around that too. And then we have Node Management and Chef Courier. So and then there's an ever-growing set of features and functions. As it relates to this topic, though, I want to focus a little bit on Courier. So as I mentioned, Courier is the run whatever, whenever, wherever orchestration tool. We released that back in 2024. Anything that that can be running anything or whatever is could be Bash PowerShell scripts similar to what you do with Ansible. Can also be inspect scans, run Chef cookbooks, and you can even run Ansible playbooks in that space. So we have an Ansible interpreter. It will go. It will execute a playbook and go. So common things our customers are using this for: patching applications and operating systems, gathering log information where you actually do limit the connectivity to those systems, verifying configuration. What's really powerful is all those steps. You can run those as one part of a job. So you can run, like, let's just say we're going to do an app update on my Ubuntu server. We do an app update. We actually take the results of that step, and then we can move it into step 2 and validate. Hey, are there updates to do? If so, do an app upgrade, and then pull the values out of that and say, hey, is a reboot needed for this update? And then we can use our reboot interpreter and update those systems.
Awesome. Thank you. So you talked about working in your lab a little bit more. One of the areas where I think would be very interesting for people to hear more about is the ability to orchestrate running an Ansible playbook. And can you tell a little bit more about that?
Yeah, absolutely. It's one of my favorite things to do, and especially with SSH being disabled. So Ansible goes, connects to a system, runs its playbook. But you can also install Ansible on a system and run that playbook locally. So you don't have to have that requirement of connecting to that system externally. You don't have to have your secrets stored somewhere. Everything happens through that agent. So, and then that step thing, I'm going to go into that a little bit more too. So if you have an Ansible, or let's say you have an Nginx playbook, and it configures Nginx on a server, and then updates the HTML page to be displayed. So every time you run that, it will apply those configurations. But why run Ansible every time? So a first step of that job is you can write an inspect test to validate that can validate that Nginx is installed and that it's running at a certain version, and even do a curl in your inspect test to validate that an object or the content of that page matches. So if everything's good, the rest of the things can be skipped. Next step is the next step is to validate if Ansible needs to be installed, right? So like, hey, I do have an issue. All right, so let's validate. Let's see if Ansible's installed and is the right version. So then it'll check to see if Ansible's installed and is a particular version. And then the next step says, hey, go install it if it's not. And then the next step is go run this playbook again, right? So you can actually get real item potency validation and item potency with your Ansible playbooks with Courier.
Awesome. So is there anything else with Chef 360 that you find really interesting and that customers can do with it?
Yeah, I mean, because everything with Chef 360 is built API first, so you can trigger those Courier jobs from anywhere. You can have a process that a button on a screen that needs to go and trigger it. You can have pipelines that trigger it. So like everything's API. All the jobs can be created through APIs, and JSON or YAML is the job format. So one of my customers is working to replace some of their user-facing Jenkins jobs that they need a button to go do a thing. Super complex, it's super slow. So they are actually looking at moving all of those Jenkins jobs over to Courier. With regards to Ansible, like Courier makes a better tower than Tower because of the way that it threads jobs. We can execute hundreds of playbooks in seconds because we're not connecting to one server at a time. Every one of those servers communicates with the Courier dispatcher through a message queuing protocol, and then all of those jobs go and they happen. Beyond Courier, our node management feature inside of Chef 360 can give you visibility into all your systems, gather vital information about the cloud environments, let you manage applications on those systems. But I think that's probably a topic that we're going to need to go for another day. So I'm really excited about what we have. Like the new Chef 360 offering is very, very cool. I've been having so much fun playing with it. Yeah, let's definitely connect again and can connect offline of this too if you have any questions, and we'll kind of wrap it up and see if you guys have anything for the group.
Yeah, so there was one question that came about, and it came about during the point in time that Kimball was talking, and I wanted to take some time and address it. I know we're running a little bit over here, but that's a good problem to have if everyone's still interested in here. And the question was, after 10,000 nodes, what typically has to be architected to support the increase? So before you take over the on-prem side, and Kimball and Mike.
No, I'm going to say the same thing you are. With SaaS, it doesn't. It's not your problem.
Yeah.
And to give a customer example to that, when we're working with Chef SaaS, we have many customers that run into this, and specifically retail. Right. So during the holiday season, when retail customers need to ramp up and they've been at a certain amount, we will see, especially during the online retailers, we'll see them, multitude of 10,000 nodes will happen within minutes. So SaaS is able to auto scale, able to go into there. Oftentimes I'll have conversations with customers before these points in times, and we'll discuss, hey, what do we think our architecture is going to look like, so we can actually ramp you up and not even have to worry about auto scaling and have a customer set up. And we get to take on that burden. We get to say, what does it actually have to do to increase, right? Auto scaling, of course, is set up on all of our nodes, so that if we're starting to see a cluster that, even though we maybe prepared them in a certain way that we thought was going to be good, we can keep that traffic going, and we can keep that traffic going at its most critical time, when your customers are obviously trying to hit your servers at scale. And so making sure that takes care of. We can have a deeper conversation about the on-prem side, and how do you increase nodes and everything like that. I think that's a great conversation for offline. Unless Mike or Kimball, you guys.
I'll go at it really quick. So the way that we're managing Chef 360, the bits that we use for the most part in cloud are what you're going to get on-prem. We architected the platform in a modern, scalable architecture that if we can scale out to hundreds of customers, you can use that same scale internally, right? So like modern architecture, we scale horizontally. It's relatively simple, and then beyond that, architecture wise, we can certainly have an offline conversation. Happy to chat with folks.
Yeah. And it's not just about the architecture of being, how you can scale it out. It's also the design philosophies behind the way Chef works, of it being a pool-based model, being designed to cache things locally, being able to splay so when you set something to run every 30 minutes, it's not always just coming in at the top and the bottom of the hour. It will automatically splay to be a little bit separate. And even if you really want to, you can configure Chef to just run off its local a local cache and not even check in with the server if you don't need it to every time. So there's a lot of just general design decisions that mean that it is designed for scale before you even need to think about scaling your server.
Yeah, awesome, great points, everyone. Again, we are running a little bit over, so I do want to give a quick conclusion about what we've talked about today, which is, again, delivering the stability, the innovation, and the future-ready automation, compliance, and job scheduling, all in a single platform. You don't need to bolt on solutions in order to have this. It's all built into one platform. It helps to unify your team and your tools, and hopefully you are able to see easy value quick. But don't just let us tell you about it. Let us show you. Contact us, and we'd be willing to run through with trials, being able to set you up with environments. And again, you've seen some of the folks that you would see during those engagements as you're talking about. And again, don't forget to check out chef.io to continue your DevOps journey. We'll stick around here for a few minutes in case there's any other questions, and we can answer those. But at this point in time, that ends our presentation. And we thank you all for taking the time to look at Chef a little bit deeper. And thank you to my fellow presenters as well.
Thanks for the invite.
Yeah, thank you very much.
Awesome. Great. Thank you, everybody. Have a great day. Talk to you later.